Hi guys, I am so pumped about today. We get to learn about trigonometry. Trigonometry is my favorite part of geometry. It is also one of my favorite things to teach when I do teach Algebra 2 trig. So you might remember some things about trig from last semester, but if you don't, that's okay. We're just going to give you the full rundown. So today we're going to be talking about just how to set up the ratios and what the ratios are. And then in the next couple lessons, we'll talk about how to use our calculator to find a missing side and find a missing angle, and then do some application problems. But today we really need to build a strong foundation, and that is identifying what trig functions are and which one we're going to use and how to set them up. So let's talk first. What is a trig function? So a trig function or a trig ratio is just a specific ratio of sides, specific ratio of two sides of a right triangle. All right, so I'm going to connect this to stuff that we already know and we've already done in the last few days, and that is special right triangles. So here you can see I have three 30, 60, 90 triangles. It's kind of hard to see because this is so small, but this angle down here is 30, 60, 30, 60, 30, 60. So they're all oriented the same way. So in a 30, 60, 90 triangle, we know the short leg, which is across from 30, is x. The long leg across from 60 is x root 3. So if this is 1 root 3. And then our hypotenuse is the short leg times 2. So 1 times 2 is 2. So that is the same pattern that we were dealing with for the last couple days. Okay, so if we compare specific sides, because all these triangles are similar, because they all have the same scale factor, then the ratios for those specific sides will always be the same. So if I compare this vertical side, which is across from 30, and the horizontal side, which is across from my 60, 1 over 1 root 3, right? That's 1 over root 3. Well, what I'm saying to you is if I compare the exact same two sides in this other triangle, because it's similar, same ratio. So if we compare the vertical side, which is 2, horizontal side, which is 2 root 3, that reduces down, 2 divided by 2 is 1, to the same ratio. Isn't that awesome? All right, same thing is going to happen here. So 4 over 4 root 3, 4 divided by 4 is 1, so that reduces down to 1 over root 3. So all of these ratios are the same as long as I'm comparing the same two sides. Same thing if I did this vertical side and the hypotenuse. So 1 over 2, 2 over 4, 4 over 8, all three of those fractions reduce down to 1/2. So as long as I'm comparing the same two sides, the specific ratio, that's the comparison of two sides of a right triangle, it'll always be the same. All right, so we have three main trig functions. So we don't just call I'm going to do the vertical side and the horizontal side. We have a name for those ratios when we pick those very specific sides. So our three main trig ratios are sine, cosine, and tangent. And hopefully those sound familiar. And your teacher probably talked a lot about these. Fun fact, though, there are actually three other ratios called the reciprocal ratios. You don't have to know this, but it'll come in handy next year. The reciprocal, do you remember what reciprocal means? That's if we were to take our fraction and flip it upside down. So instead of doing vertical side over horizontal side, if I did horizontal side over vertical side and flipped it upside down, that would be the reciprocal. Well, they have different names once you flipped them over. So we have the reciprocal of sine, which is cosecant. The reciprocal of cosine, which is secant. And the reciprocal of tangent, which is cotangent. So these are the ones we are going to focus on. These just made you smarter, and you'll be ahead of everybody in your class next year for your trig section in Algebra 2 trig. All right, so let's talk about what sine is. So sine is a very specific ratio. It is, first of all, abbreviated SIN, and you probably noticed that on your calculator when you were actually doing this. So it is really important to make sure we sound like we know what we're talking about too. So SIN in normal terms, we would pronounce that sin, but when you're in the math class, you need to train your brain so whenever you see that, you say sine, even though it looks like sin. We have to train ourselves to do that. All right, so the sine is the ratio. Do you remember which two sides? opposite over hypotenuse. Now, before we can know what the opposite side is and what our hypotenuse is, we have to know what our reference angle is. So I don't have a spot for this, so I'm going to write that right here. So our reference angle is the angle we are looking from. So why that's important is because if we were standing right here, actually I always like to call this guy Bob. If Bob is standing right here, then opposite of Bob is all the way across the triangle, that's 4. But if Bob moves over here, then opposite of Bob all the way across the triangle is 4 root 3. So depending on where Bob is standing, the opposite side will be different. So it's really important to know what our reference angle is and where Bob is standing. Now, Bob will never stand at the 90-degree angle. He will only be at one of the acute angles. So only one of the acute angles. All right, so that's a really important vocab word. Okay, so when we do sine, we have to tell people where Bob was standing, what our reference angle is. So if you know the angle measurement, you would write sine of 30, sine of 60, wherever Bob was standing. If you don't know where he's standing, or you don't know the angle measurement of where he's standing, then you use a Greek letter as its variable. And most often we use theta, which is like an O with kind of like a belt, like a line through the middle. So if I didn't know that this was 30, I could also call it theta, and I would tell people Bob is standing at theta. So theta is our 30 degrees in this one, or if Bob was standing here, it would be the 60, but either way, sine is opposite over hypotenuse. So we're always going to choose the opposite and the hypotenuse. So if our triangle is like this, and we'll put Bob here, so there's our theta. Then opposite of Bob would be this side here, the horizontal bit, and then the hypotenuse is always the side across from the 90-degree angle. So we would choose those two sides. All right, our next trig function, our next trig ratio is cosine, and it's abbreviated. You can see it right on your calculator as COS. And some people call it cos. I always say cosine even when I see the abbreviation. So again, it's really important when you are using a trig function to tell people where you're standing. So you always have to follow it by an angle measurement. If you don't know the angle measurement, you can use a Greek letter. And for cosine, instead of opposite over hypotenuse, do you remember which two sides this one is? It's adjacent over hypotenuse. All right, so what does adjacent mean? Well, adjacent is the side that's next to Bob, next to your reference angle, but not the hypotenuse. So in this case here, if Bob is standing at the 30, opposite would be 4, because that's all the way across, and adjacent would be the 4 root 3. So it's actually touching our reference angle, but it's not the hypotenuse. Now, Bob can never stand here at the right angle, because if you were to try to do sine as opposite over hypotenuse, well, opposite would be 8 and the hypotenuse is 8? That's confusing. And what about adjacent? Wouldn't there be 2 adjacent sides and 1 hypotenuse? So that's why Bob is always going to stand at one of those 2 acute angles and never the right angle. So I'm going to draw my triangle a little bit differently just so we don't get used to it always looking like this. So if I drew my triangle like this and put theta right here, so Bob is standing here, my hypotenuse is always across from the 90-degree angle. That one's easy to spot. The adjacent side is going to be the one that's helping to make the angle of theta. So the hypotenuse and the adjacent side will always make your reference angle. All right, and then our last one is tangent, abbreviated TAN. So tangent. Now I'm going to pick a different Greek letter this time, just so you know that there's more than one Greek letter. I'm going to use alpha. So alpha is the first letter of the Greek alphabet, and it looks kind of like a little fish. Now you can use whatever you like here. You can actually use X's and Y's, but mathematicians for angle measurements do like to use those Greek letters. So a tangent of alpha, so we've already done opposite over hypotenuse and adjacent over hypotenuse. So tangent is our last one, and that's opposite over adjacent. All right, so I'm going to draw my triangle a little bit differently again. So this time I'm going to have an alpha instead of a theta. So I'm going to put my little fish guy in there. There's Bob. So opposite would be across, and adjacent would be next to. Okay, so just going back really quickly to our reciprocal functions. That's what these are, reciprocal functions. The reciprocal of sine is cosecant, which means if you were going to do cosecant, you would do hypotenuse over opposite. The reciprocal of cosine is secant, so if you were going to do secant, you would do hypotenuse over adjacent. You literally just flip it upside down. And then same thing for tangent and cotangent. You would flip it over, adjacent over opposite, to give you cotangent. So you'll talk about those maybe next year in Algebra 2 trig, but we don't have to worry about them, but I did want to mention them. All right, this guy right here is going to be our friend. So SOHCAHTOA is just the silly way to remember which sides each trig function uses. So SOH is sine, and that uses opposite and hypotenuse. CAH is cosine, and that uses adjacent and hypotenuse. And then TOA is tangent, and it uses opposite and adjacent. So I write this down on the top of every paper and every note sheet that I have, so I never have to flip back and forth. It is so handy to have that visual right in front of you, so you don't have to try to figure out the problem and try to remember like which sides are which. Okay, so let's put some of this to good use. So you can see we have a right triangle. Our side lengths are already 3, 4, and 5. This angle down here is theta, and this angle up here is alpha. So if I want to find the sine of theta, that means Bob is standing at theta. So I'm going to put Bob right here. The other thing I really suggest that you do before you do any of the math is label your sides. So which one's opposite, which one's adjacent, which one's hypotenuse. So opposite is the 4, adjacent is the 3, and hypotenuse is the 5. So opposite is all the way across, hypotenuse is across from the 90-degree angle. So if you're ever a little bit confused on adjacent, save that one for last because there's only 3 possible sides. All right, so then for sine, we want to choose sine as opposite and hypotenuse. So we want the opposite side and the hypotenuse, so it will be 4 over 5. Cosine would be, cosine is adjacent and hypotenuse. So adjacent is 3, hypotenuse is 5, 3 over 5. And then tangent, TOA, is opposite and adjacent. So opposite is 4, adjacent is 3. So guys, I cannot stress enough, for those of you who struggle in like tests and quizzes and remembering things, even on homework assignments, like write down as much as you can to give yourself like hints and keywords and ways to help you figure things out a little bit quicker. If you write down SOHCAHTOA, then you don't have to try to figure out the ratio and figure out which sides you need. If you write opposite, adjacent, and hypotenuse on your picture, then you don't have to try to figure out your ratio and figure out which side is which. Like, give your brain a break and like just pick. Well, I know it's opposite and hypotenuse. I've already labeled opposite. I've already labeled hypotenuse. Bam, I know my fraction. So use that as a way to kind of help ease you along. Now, if I wanted instead to do the sine of alpha, what changes? Well, Bob would move, right? Now Bob has to stand at alpha. What else changes? Does the hypotenuse change? Well, no, because the hypotenuse has to be across from the right angle. Okay, so that'll stay. Does the opposite side change? Yes. Now these two guys would have to switch spots, right? Because opposite of Bob is 3, and adjacent next to Bob would be 4. So it's really important to know where you're standing because that'll totally change your ratio. So if I do change my ratio, and this is now my adjacent side, and this guy's my opposite side, then when I do sine, opposite over hypotenuse, now my fraction is 3 over 5 instead of 4 over 5. So it makes a big difference where you're standing, so it's really important to make sure you know what your reference angle is. All right, let's look at this guy. We are going to find the sine of A, the cosine of B, and the tangent of B. So you can see in this picture I don't have a theta and an alpha, so I'm going to ask you to find the sine of A, so that just tells us Bob is standing at A. When we find the cosine of B, that tells us Bob is going to move to B. So you don't have to have the theta and the alpha, you can just use the vertex letters that are there. Okay, so sine is opposite over hypotenuse. So we want opposite. So if we're standing at A, opposite would be 30, right? And hypotenuse, oh shoot, we don't know that. Okay, we could put an X here, but if we know two sides of a right triangle, can't we find the third? All right, pause the video, find X. How long is the hypotenuse? All right, so 16 squared plus 30 squared equals x squared. So, oh, these are big numbers. 16 times 16, 256 plus 900 equals x squared. So 1156 equals x squared. We're going to square root both sides. And x equals 34. All right, so this equals 34. So anytime you know two sides of your right triangle, go ahead and find the third side. Don't ever write your fraction with an x in it. If you can find that third side, go ahead and do it. All right, so we decided we're going to use opposite and hypotenuse. So opposite is 30. Hypotenuse we now know is 34. Now you can reduce this, but I'm okay if you just leave it like that. If you wanted to reduce this, divide them both by 2 because they're both even. And you'd get 15 over 17. So this is okay, that's okay, either one. All right, what if we do cosine of B? Well, Bob has to move to B, right? Will anything else change? Well, the opposite side would move. Now would be 16. And the 30 becomes my adjacent side. So cosine is adjacent over hypotenuse. So adjacent is 30, hypotenuse is 34. Oh, that's interesting. Do you see that they have the same ratio? Why does that happen? Well, because Bob is moving to a different angle, the side that was opposite for opposite and hypotenuse is now the adjacent over hypotenuse. So these ratios can be the same as long as we're standing at different angles. All right, our last one is tangent of B. Does Bob need to move now? So Bob is already at B. We've already got it labeled as opposite and adjacent, so he does not need to move. So we just need to pick the correct two sides. So opposite over adjacent, 16 over 30. And again, if you want to reduce these, you totally can. If you want to leave them, that is okay as well. All right, so now we've kind of got that going. We're going to actually start looking at problems. We're not going to find the missing parts yet. We're just going to choose a ratio to help us find it, and then going forward, we're going to solve them. Now, you might remember how to solve them, but today we're not going to work that hard. We're just going to set them up. All right, so we're going to write a trig function, one to find x and one to find y. So each one of these is going to have two trig functions. So first of all, decide which one you want to do first, x or y. It literally doesn't matter. Just pick one. Most people like to go in alphabetical order, so that's what we'll do. We're going to find x first. So literally, I'm going to cover up y. Okay, so do that on your paper, cover up y. Give your brain only two things to focus on instead of all of that, okay? So we have the 90-degree angle. Remember, Bob will never stand there. Bob can stand at either one of these angles. It doesn't matter which one, but since we already know this is 54, I'm going to put Bob here. If Bob wants to stand up here, you would have to find this angle measurement, but we don't need it if we know this one. If you want to put Bob here, totally fine, but you're going to have to find this angle first. All right, so like I said, I like to write SOHCAHTOA on the top of everything. so I don't have to think that hard. Okay, so if Bob is standing here, next thing we're gonna do is label our sides. So this is opposite. This guy is our hypotenuse. All right, if Bob is standing right here and we want to find x and we have the opposite and the hypotenuse, which trig function will we use? Opposite and hypotenuse is going to be sine. So we're going to do sine of, where's Bob? 54 equals, has to be opposite on top, has to be hypotenuse on the bottom, x over 9. We're going to stop right there. We're done for today. That's it. Okay? Tomorrow we'll actually solve x. You might remember how to solve x. Awesome. We're not going to work that hard today. All right, now we're going to find y. So I'm literally going to cover up x this time. So I already started to label, but because this was covered, I didn't label this side. So if this is opposite, then this has to be adjacent. Bob doesn't have to move. He can stay at the 54. So now I need the trig function for adjacent and hypotenuse. That's cosine. So cosine, where Bob is standing, 54 equals, adjacent has to be on top, hypotenuse has to be on the bottom. That's it, we're done. Tomorrow we'll solve them, today we're just setting them up. Okay, so I want you to try this one. Try to set up a trig function for A, try to set up a trig function for C. Bob can stand at either one of these angles, but if you want Bob to stand at A, you need to find this angle measurement. So pause the video, see what you can do. All right, I'm going to actually put Bob here. I don't want to work that hard. So I'm going to label my sides now. So 12 is opposite. C is hypotenuse. A is adjacent. I'm going to decide, I'm just going to go in alphabetical order. So I'm going to find the adjacent side first. I'm going to cover up C. So the two sides I have are opposite and adjacent. So that's going to be tangent. So tangent of 22, because that's where Bob is standing at the 22, equals, it has to be opposite on top, so 12 over A. That's it, we're done. Now I'm going to find C. So the two sides I've already labeled are opposite and hypotenuse, so that's sine. So sine of 22 equals, opposite has to go on top, 12 over C. How'd you do? Did you get them figured out? All right, let's move to angles. What if we want to find angles instead of sides? Well, we're going to start out the same way, except we have to decide ahead of time, what do we want to find first, theta or alpha? So we can definitely find the length of the side using the Pythagorean theorem. We don't need to in this case, because when we set up a trig function, we only need two sides, right? But if you'd like to find this using the Pythagorean theorem, please feel free to do that. Can find using Pythag. All right, I'm going to find theta first, so I'm going to put Bob right here. I'm going to cover up alpha, because I don't need it, and I'm going to label my sides. So 22 would be opposite, 19 is adjacent. Our hypotenuse, we don't have any information on, so it's not going to help us anyway. All right, so opposite and adjacent. Opposite and adjacent, that's tangent. So tangent of, where's Bob standing? We don't know how big that angle is, so tangent of theta equals, opposite has to go on top, adjacent has to go on bottom. All right, now we need to find alpha. Now if we need to find alpha, where's Bob need to go? To alpha. So if Bob moves, then what changes? Well, the hypotenuse isn't going to change. It's always across from the 90-degree angle, but your opposite and adjacent are going to switch places now. So my opposite and my adjacent will switch. And I don't need theta, and I don't need my hypotenuse. Well, I still have the same two sides, so it's still the same trig function, but we're standing at alpha instead of theta. And opposite and adjacent are opposite of that one, aren't they? They're flipped over. Isn't that interesting? That's it, we're done. Next week, we'll figure out how to solve this, or we'll remind ourselves how to solve it, but today we're done. That's it, we're not working that hard. All right, last one. For example 6, I need you to pause the video and see if you can figure out angle A, set up a trig function for angle A, set up a trig function for B. You don't need to solve it, just set it up. So first you have to decide what you're going to solve for first. I'm going to just go alphabetical order. I'm going to put Bob here. Opposite of Bob would be this guy. Hypotenuse here, adjacent here. Oh, that's funny. My D and my J got smushed. Okay, don't need B, don't need the opposite side because there's no information there. Adjacent hypotenuse. That would be cosine. Cosine of A, because that's where Bob is standing. Adjacent over hypotenuse. Now again, you can reduce this if you want, but you don't need to. We can leave it as 12 over 22. Bob needs to move to B, so I'm going to move Bob to B. What changes? The adjacent side and the opposite side will switch. So opposite, adjacent. Still don't need this side. Don't need this. What do we have? Opposite and hypotenuse this time. So that would be sine. Opposite and hypotenuse. So 12 over 22, opposite still has to go on top. That's it, we're done. All right, if you have questions about this, please reach out. Otherwise, we're going to keep getting more practice with this as we start solving these. So if you're not 100% yet, it's okay. Otherwise, have a fantastic day, and we'll see you again soon.